DragonLLM is announcing Dragon, a new LLM architecture that is both efficient and high-performing. It is designed for faster and smarter long-context applications like RAG and agentic reasoning. Let's look under the hood. When you query an LLM, you provide inputs like questions, code or documents that it processes internally before producing an output. That internal process, how the computation is structured, is a model's architecture. It's this architecture that drives macroscopic behaviors such as inference cost and capabilities. Today, most major players in generative AI have settled on the transformer architecture. We're open sourcing a new architecture called Dragon, based on the Mamba research line. Dragon's key advantage over transformers is the speed at which it can process and generate text. Where the transformer slows down as a generated document grows, Dragon generates text at a constant speed, no matter how large the past context is. This directly makes Dragon cheaper to serve at inference. It costs less to serve a Dragon-based model than a transformer-based model, or, put another way, on the same hardware, you can serve more users with Dragon than with a transformer. For example, when processing a 64K token sequence, a 3B transformer uses around 10 gigabytes of memory, whereas Dragon uses 2 gigabytes, so that's 5 times less memory for the same quality. To demonstrate our architecture's potential, we're releasing a preview of Dragon 3B, a foundation model trained on 3.7 trillion tokens available on Hugging Face. As winner of the European Commission's Large AI Grand Challenge, we trained it on Leonardo and Jupiter, two supercomputers located in Italy and Germany. On language modeling, Dragon 3B matches or surpasses similarly sized models trained on much more data. The Dragon architecture thus also lowers the training costs because you reach the same performance as a transformer training on less data and thus less compute. Another strength of our architecture is recall, the ability to retrieve specific information from long contexts of words. This is especially useful in applications that involve processing long documents like contracts or code bases. This gives Dragon a distinct edge, as usually architectures based on Mamba have weaker recall performances. In conclusion, we present Dragon, an LLM architecture that lowers both inference and training costs. It will power our next generation LLMs in the near future. You can try the preview model and read more about it on Hugging Face today.